The next circuit which we will try to understand is of course the circuit disadvantage of the circuit which has to be understood is disadvantage of direct coupled amplifier. First we will try to understand what are the advantage of direct coupled amplifier over the RC coupled amplifier. In the previous video we have already understood the disadvantage of RC coupled amplifier. Now we will try to understand the disadvantage of direct coupled amplifier, but before that we will try to understand the advantages of direct coupled amplifier. Now what was the first disadvantage of RC coupled amplifier? At low frequency the capacitive reactance is high, therefore gain will decrease. So what we did is, in direct coupled amplifier we have removed the capacitor. So if no coupling capacitor is there, that is why it is called as direct coupled amplifier. Okay, direct coupled amplifier, no coupling capacitor. So if capacitor is not there, there is no problem of low frequency. So low frequency signal will be amplified. So low frequency signal will have a straight line. At mid frequency the gain was already constant. And at high frequency, what was the second disadvantage? The second disadvantage was at high frequency the amplification factor of the transistor decreases, which decreases the gain of the which decreases the gain of the amplifier at high frequency. Now that is because of all the transistors were NPN and they are connected in common emitter configuration. In here direct coupled amplifier, if the first stage is NPN, the second transistor will be PNP, so arrow mark will be outward. The third will again be NPN. Okay, so if you use complementary transistor, the amplification factor does not get affect at high frequency. So at high frequency also the gain remains constant. So you get a straight line, that means gain remains constant for all frequencies. So all the disadvantage. And the third disadvantage was limited bandwidth. Here the bandwidth is infinite, all frequencies can be amplified, and the last stage is DC signal cannot be amplified. Here DC signal also can be amplified. So all the disadvantage related to RC coupled will be removed by direct coupled amplifier. But a very important point you can note in the circuit diagram is that the biasing resistance are missing, which was an important factor in case of RC coupled amplifier to keep its operating point stable, constant between that of saturation and cutoff, right? As I told you, if you draw, so this is the saturation point and this is the cutoff point. So operating point should be stable so that both the half cycles be amplified. So operating point should be stable, and that was because of the biasing resistance. But in case of direct coupled amplifier, you have to use minimum number of resistors. So what we did is we removed the biasing resistance because we have to keep RC1. This collector resistance has to be kept as it is because this is the point where the output voltage is there and output voltage can be connected to the input of the second stage. So we removed the biasing resistance. So the disadvantage is, in the absence of biasing resistance, the operating point will shift, and in electronic terms this is called as drift. So we say in the absence of biasing resistance, drift is observed in direct coupled amplifier. That is the first disadvantage. And the second disadvantage is, see, again I am taking the same example that each stage has a gain of 10. 1 volt is applied at the input, output of the first will be 10 volt, 100 volt and then 1000 volt. Now suppose this circuit is kept in a noisy environment. In electronic terms, noise means disturbance of electrical signals. Okay, so say small noise of 0.2 volts appear at the input. So now what will be the input? Input will be 1.2 volt. So when it will be multiplied by the gain, it will be 12 volt at the first stage, it will be 120 volt at the third stage, and it will be 1200 volt at the output. How much was expected? 1000 volt. How much you are getting? 1200 volts. This 2400 volt is a very significant value, which is nothing but a noise. So this is an unwanted output. So that is the disadvantage of direct coupled amplifier. A small noise at the input is amplified to a significant value at the output. So the first disadvantage which was related to direct coupled amplifier, in the absence of biasing resistance, drift is observed in direct coupled amplifier. So this is the disadvantage related to direct coupled amplifier. Second is small noise at the input is amplified to a significant value which is unwanted, bracket में लिखेंगे unwanted at the output. So these are the two disadvantages of direct coupled amplifier. And now of course in the next video we will try to understand working of differential amplifier. This differential amplifier removes the disadvantage of direct coupled amplifier. Differential amplifier is also an example of direct coupled amplifier, but all the disadvantage related to direct coupled amplifier will be removed by differential amplifier. So we will try to understand working and construction of differential amplifier, and once that is done, then we will use differential amplifier to design operational amplifier. I hope you have understood. Hello students, in the previous video we tried to understand disadvantage related to RC coupled and direct coupled amplifier. The disadvantage which was there in RC coupled amplifier was removed by using direct coupled amplifier, but direct coupled amplifier also had disadvantage that in the absence of biasing resistance, drift will be observed, and a small noise at the input will be amplified at the output. So both these disadvantage can be removed by using differential amplifier. So we will design differential amplifier, we will try to understand the construction part, we will try to understand how the differential amplifier removes the disadvantage related to direct coupled amplifier, and the working of differential amplifier. Okay, so this question can be asked for 3 marks, so this is very, very important. Now in a differential amplifier is also an example of direct coupled amplifier. Why we say it as a direct coupled amplifier? Because output of the first stage is directly connected to the input of the next stage. That type of multi-stage amplifiers will be called as direct coupled amplifier. So as I said, differential amplifier is also an example of direct coupled amplifier. See how the circuit diagram is drawn. Okay, so this is the first transistor and this is the second transistor, and in this case emitter of the two transistor, I will call it as Q1 and Q2, are coupled together. In the previous video when we tried to understand a disadvantage of RC and direct coupled amplifier, we saw that the collector of the first was connected to the base of the second, collector of the second connected to the base of the third, and that is how it was connected. In this case this is also a direct coupled amplifier, but emitter of the two transistors are connected together. Okay, and then these two transistors also has the biasing resistance. The two transistor will also have biasing resistance. I will call it as R1, RB1, R2, RB2, and then this is RC1, this is RC2, this is one output VA, this is one output VB, and as the current will flow through the collector of transistor, I will call it as IC1, and here it will be IC2. Okay, now in all those previous circuits, RC coupled and direct coupled, we used only one power supply. In case of differential amplifier, we will be using two power supply, plus VCC, and there is a emitter resistance RC and minus VCC, a positive supply and a negative supply. Okay, so I will draw it here. It will be like this: positive, negative, positive, negative, and here it will be, this is for negative, positive, negative, positive. Okay, so this is plus VCC and this is minus VCC, and the common terminal of these two will be considered as ground. Okay, the common terminal of these two will be considered as ground, which will be the ground for the base resistance. Okay, I will tell you later why these two supplies are necessary. Okay, first let us try to understand how this differential amplifier removes the disadvantage related to direct coupled amplifier. Please recollect what we said for a direct coupled amplifier. For a direct coupled amplifier, what we said is the disadvantage is in the absence of biasing resistance, drift is observed. Now what you can see is in this, both the transistors Q1 and Q2 has biasing resistance R1, RB1, R2, RB2. So of course, if biasing resistance are there, operating point is stable, and if operating point is stable exactly between saturation and cutoff, see this is what we have, right? Saturation and cutoff, and the operating point should be exactly at the center, so that both positive as well as negative half cycle should be amplified. So the operating point will be stable because of R1, RB1 and R2, RB2. Okay, so the first disadvantage is removed. Now by this design, what we can see is, now instead of one input, one output, we have two inputs and two outputs. Okay, two inputs and two outputs. So the output is the difference between the two input voltage. Okay, that is why it is called as differential amplifier. So now in a differential amplifier, when you apply input at V1, V2 will be ground. If you apply voltage at V2 or input at V2, V1 will be ground. Okay, suppose V2 is ground and input is applied to V1. So this is 1 volt, and here as it is connected to ground, it will be 0 volt. Now suppose if you keep this entire amplifier in a noisy environment. What do you mean by noisy environment? Where the circuit can pick up stray signals. Okay, that is what we have mentioned in the second disadvantage of direct coupled amplifier. So it can pick up a small voltage. Say if it becomes small voltage, say that 0.2 volt, so that 0.2 volt will be common for both the inputs in this case, and the output will be the difference. The output, amplified output, will be the difference between the two. So it will be 1.2 minus 0.2, that will be 1 volt. The signal which is going to amplify will be 1 volt. So any kind of noise or disturbance which will come, it will come as common signal, and the differential amplifier has the ability to reject common signal and amplify only the difference of the two signals, and that is how it got its name as differential amplifier. Okay, it will amplify the difference between the two input signals. So by default, what will happen? The common signal, that is noise, will be always rejected at the input. I hope you have understood. Okay, so both the disadvantage of direct coupled amplifier is removed by using differential amplifier. Okay, now the second part again is very important, that I said instead of one power supply we are using two power supply, and the common terminal of these two will be connected as ground. Okay, let us imagine, just imagine that, say we have just only one supply and a ground. Okay, so this ground, this is ground, this is ground, all this will be. Now as soon as input is applied, okay, input voltage is applied, this is the input source, right? A source is connected with respect to ground, right? Now if common ground is not used and a normal circuit ground is used, what happens is, as soon as a source is connected, this source comes in parallel with the biasing resistance RB1. Okay, now always whenever our source is designed, we have to make sure that the internal resistance of the source is very high, the output resistance of the source should be low, so that this is the source which will be always designed as if the output resistance of this source is low. That means, see what happens is, now when the source was not connected, current was flowing through R1, the same current was flowing through RB1, and this voltage drop which was produced across RB1 was biasing the base emitter junction of transistor Q1, which is the forward bias junction, right? So if it is properly biased, the operating point will be exactly at stable position, that is between that of saturation and cutoff. Now, but as soon as a source is connected with low output resistance, so the output resistance of source comes in parallel with the biasing resistance, and you know current always takes least resistance path. So the current which has to flow through RB1 has got a low resistance path through the source to go to the ground. That means current through RB1 will decrease, which will decrease the biasing voltage or voltage across RB1, which will be decrease the biasing voltage of base emitter junction of Q1. So Q1, the biasing potential will change, either it will go towards saturation or it will go towards cutoff. And as Q1 is directly connected to Q2, any change in Q1 will produce change in Q2. So Q2, biasing condition of Q2 will also change. And will there be a proper amplification which will be given at the output? No, either the positive half cycle will be amplified or the negative half cycle will be amplified. So amplification will not be proper if you always use circuit ground, okay, or you use only one power supply. So what we did is, we instead of using one power supply, we used two power supply, and the common terminal of this terminal will be taken as the ground. Okay, that is the common ground of the circuit. Now, but when the source is connected, this ground is the circuit ground, this is the common ground, so this cannot come in parallel. If they cannot come in parallel, all the input current which was flowing through R1, the same current will flow through RB2, which will keep the voltage across RB1 proper, so that Q1 and Q2 are properly biased. So that is why instead of one power supply, we use two power supply. Okay, so this is about the advantage of differential amplifier and the basic concept of why two power supplies are required in a differential amplifier. Okay, now when the circuit is designed, differential amplifier, the circuit should be symmetrical. Okay, symmetrical means RC1 should be equals to RC2, Q1 should be equal to Q2, R1 should be equal to R2, RB1 equals to RB2. Okay, so this is the thing which has to be there, and this negative source minus VCC acts as a constant current source for both Q1 and Q2. So for Q1, this is emitter current IE1, this is for Q2 the emitter current IE2. As minus VCC acts as a constant current source, IE1 plus IE2 should remain constant always. Okay, now as I said, we have two outputs, so depending upon how the output is taken, see, the output can be taken between VA and VB. It can be taken VA with respect to ground, or it can be taken as VB with respect to ground. Okay, so generally that is what we will try to understand. We will take the output voltage VA with respect to ground or VB with respect to ground. So what will be the voltage at VA? For this transistor, the total voltage is plus VCC. Some voltage will be dropped across the resistance and current which is flowing through the collector region, that is RC1 into IC1, remaining all the voltage will be dropped across VA with respect to ground. So VA, the formula for VA will be the total voltage plus VCC minus IC1 into RC1 minus IC1 into RC1. Similarly, VB, it will be total voltage plus VCC minus IC2 into RC2. And in both this equation, what you can see is VCC and VCC, RC1, RC2 are constant. So VA depends upon IC1 and VB depends upon IC2. Okay. So when you apply an input signal, the variation will produce two different outputs at VA and VB. So that is your working of differential amplifier. So this is the construction part of and advantage of differential amplifier. I hope you have understood.